Hey, it's Coach Reeves. Today we're going to talk about graphing square root functions, okay? You're going to see a lot of similarities to when we did quadratics and when we did absolute value. There's only one new wrinkle, but I'll show you that in just a second, okay? So the A value will still tell us if we have a vertical stretch or a vertical compression, or we also call it a shrink sometimes. The A also, if you see that negative sign up front, tells you if you're going to have a vertical reflection over the x-axis or not, okay? The B, that's what's new. If we happen to have a minus sign or a negative sign inside that radical right there, the new thing is we're going to have what's called a horizontal reflection over the y-axis. And we haven't done it before, but it could show up today, and it will. I'll show you how to do it. The H, underneath the radical is the same thing as being inside the parentheses squared for a quadratic. The same thing as being inside the absolute value brackets. We're thinking opposite. So instead of going right, we're going to shift left. Instead of going left, we're going to shift right. Okay? And you'll remember once we get going. And the K value is still the K value. It's going to tell us if we're going to shift up or shift down with our vertical translations. Okay? All right, let's jump into this. All right, so real quick, my parent function. This first equation is our parent function. This is what we're going to build off of today. Okay? So if I make a little T-chart, and I have my x's and my y's, and we're going to work off the square root of x, y equals the square root of x, we're going to pick numbers that are perfect squares. Okay? So we won't end up with decimals, and it makes it tough and it's ugly. So we're going to use 0, 4, 9. Now we're going to stop at 9 because if I get any bigger, it won't fit on the graph. Okay? And we're going to say the square root of 0 is 0. The square root of 1 is 1. The square root of 4 is 2. And the square root of 9 is 3. So when we plot these points, we're going to be at 0, 0, the origin, 1, 1. And the square root of 4 is 2. And the square root of 9 is 3. So we're going to have a little graph that looks like that. And that's our parent function. Okay? But then we do this. We're going to make our first transformation. We're going to have a negative in front of the radical, which is what we call a vertical reflection over the x-axis. Okay? So all we're doing is reflecting. So you could do this to your chart. You could come over here and go times -1 if you needed to. But all we're going to do is make a vertical reflection, and we're going to go to the right 1, but we're going to go down 1. To the right 4, down 2. To the right 9, down 3. And we're going to have our little vertical reflection. The next we're going to do is this equation. The negative is inside the radical. This is the new one. This is the horizontal reflection over the y-axis. We're going the other way. So, same pattern. You're still going to start at the origin, but this time we're going to go to the left 1 and be up 1. To the left 4 and up 2. To the left 9 and up 3. This is what a horizontal reflection would look like. Okay? All right, let's talk about stretches and compressions. Let me put the parent function back up there at 1, 1 and 4, 2 and 9, 3. And let's talk about a stretch. What if I gave you something that looked like this? Y equals 2 times the square root of x. That means we're going to be twice as high as normal. We're going to stretch it by a factor of 2. Okay? What we could do to help you if you wanted to, we could drop in. Let me clear some of this out. We could drop in and we could multiply times 2 times 2 times 2 times 2. And this would be at 0, 2, 4, 6. So when we plot these points, that we're going to be at 0, 0. We're going to be at 1, 2. We're going to be at 4, 4. and we're going to be at 9, 6. 4, 5, 6. And my graph would look like that. It's higher. It is twice as high as it usually is. Instead of being at 1, instead of being at 1, we're at 2. Instead of being at 2, we're at 4. Instead of being at 3, we're at 6. We've been multiplied by a factor of 2. Let's try this. What if I gave you this? Y equals 1/2 square root of x. Now that's my new scale factor, or that's my new factor, okay? Let me erase this. We'll try it out with the 1/2. Okay? There we go. So times 1/2 would still be 0. Times 1/2 would put me at 1/2. Times 1/2 would put me equal to 1. Times 1/2 would put me at 1.5. Okay? It's easier with decimal sometimes. All right, so we're going to start at the origin. We're still at 0, 0. Except when we go to when we go to 1, we're going to be at halfway up. We're going to be at half. When we go 4, we're going to be at 1. When we go to 9, we'll be at 1.5 or 1.5. And we're going to be a little flatter. We're flatter because we're being compressed vertically. Got it? All right, let's try some more. What about if we shift left or right? Okay, let's put our parent function up. We're still at the origin. We're at 1, 1. We're at 4, 2. And we're at 9, 3. And then we're going to do this. We're going to ask you to shift it. Let's say that I gave you y equals the square root of x plus 4. Remember, if it's underneath the radical, we're going to do this. We're going to ask you to think opposite. Opposite. So normally we would think a plus 4 would shift 4 units to the right. But since we're underneath the radical, we're going to shift this 4 units to the left, and we're going to be at -4. It says we're going to go left 4 units. Okay? And now once we just shift left 4 from our starting point, we just apply the normal pattern of square root of 1 is 1, the square root of 4 is 2, and the square root of 9 is 3. And this would what it would look like if we just shifted to the left 4 units. If we're going to shift to the right, y equals, let's try this, the square root of x, let's just say -2. This would be to the right 2 units. So instead of starting at 0, 0, the origin, we're going to shift to the right 2 units. And then we'll do our normal pattern for the square roots. We would go 1, 1. We would go 4, 2. And then we would have no room. We don't have enough room, so we're just going to go right there. We don't have room to go 9, 3. Okay? Simple enough. All right, let's go our k value. Let's talk about vertical shift up and down. Okay? Parent function, origin, 1, 1, 4, 2, 9, 3. All right, so let's go do this. Y equals the square root of x, and then we're going to go +5. Now notice that the +5 is outside or past the radical. Be careful. If it's underneath the radical, then it's left or right. Make sure that it's past it, so we'll shift up and down. So this just tells me to do a vertical shift up 5 units. So we're going to just go, instead of starting at the origin, we're going to start 5 units higher than normal. And then apply the normal pattern of the square root of 1 is 1, the square root of 4 is 2, the square root of 9 is 3. And then we connect our dots, and there's our graph. And we could also shift down. I could give you this. I could say that y equals the square root of x -3. And this tells me to start 3 units lower than normal. We would be down here at -3 and apply the pattern of the square root of 1 is 1, the square root of 4 is 2, the square root of 9 is 3. And that would put us somewhere there. Got it? All right, let's try a couple of examples. Okay. All right, on these examples, we're not only going to graph them, we're going to list our transformations, and we're going to talk about domain and range. Okay? So on this problem, let me put the parent function up there so we can compare. 4, 2. I don't have room for 9. So my graph is just going to look something like that. Okay? All right, so what are they asking me to do? Well, let's talk about our transformations. This negative sign right here, this negative, says we're going to have a vertical reflection. What about the 1/2? The 1/2 tells us that we're going to have a vertical compression by a factor of 1/2. Kind of abbreviate that a little bit. And then what about the 4? The +4. Remember, we're thinking opposite. We're thinking opposite, so we're going to say we're going to have a horizontal shift. Or you can say translation. Okay? We're going to have a horizontal shift. In this case, we're going to go left 4 units. Okay? So what's that going to look like? Well, we know that it's going to be a vertical reflection. We're going to go down instead of up. Okay? Since we're going to have a vertical compression, okay, or a vertical shrink, we're going to be squeezed, we're going to be compressed, we're going to be flatter, and we're going to get wider, maybe skinnier, okay? And then we're going to have a shift to the left 4. So the first thing we're going to do is we're going to shift left 4, and we're going to start right there at -4. And then we're going to go 1, but instead of going all the way, the square root of 1 is 1, we're going to say 1/2 of that. And then the square root of 4 is 1. Instead of 2, we're going to say is 1. And then instead of 9, we're going to go 1/2. So our graph should look something like this. Okay? And if we were going to talk about the domain of that purple graph, we would say my domain, I am starting at -4. Hard bracket, and I'm going to go to the right infinity, a positive infinity. As far as the range goes, the range for the graph, the low point of that graph, I'm down here and I'm going to -infinity forever, so we're going to say -infinity is my low point. My high point is at 0. And that's what we would do for that one. Okay? All right, let's try the next example. Let me erase something a little bit, give us a little bit of room. Okay? All right, so what does this tell us? We're going to talk about our transformations. Okay? Our transformations. That 2, the 2 in front tells us we're going to have a vertical stretch by 2. The x plus 3, that's going to be a horizontal shift. Now that's a plus 3, so we're thinking opposite. This is going to be left 3. Just like this, we're going to go left 3. And this is our K value. We're going to have a vertical shift down 4. We're going to have a vertical shift, you can say translation, down 4. Now, you want to do your translations or your shifts before you do your stretch or your shrink, okay? You need to find your starting point. In this case, my starting point tells me to do what? It says to go left 3, down 4. So I'm going to go left 3, down 4, and that is my starting point. Always look at your transformations and find out where you're going to start. Now, I do not have a reflection, so we're going to go up, but we're going to be stretched by a factor of 2. So my normal pattern would be 1, 1, but we're going to go 1 twice as high. Let's draw your normal pattern. 1, 1, 4, 1, 2, 3, 4 is 2, and then we go 9, and then we would go 3. This would be my normal pattern, but we're going to stretch by a factor of 2. So we need to be twice as high. So we went, instead of going 1, we went 2. Instead of 1, 2, 3, 4, 1, 2, we're going to be twice as high. Instead of being at 9, 3, we're going to be at 9, 6. So actually, this purple graph is the one with the vertical stretch by 2 also. Okay? So let's look at our purple graph. What is our domain and range? Well, my starting point for my domain, my starting point is at -3. And I'm going to positive infinity. As far as the range goes, my low point, we're going to start with the low point. The low point is down here at -4. And it's going up forever, so that's going to be positive infinity also. Okay? It doesn't get much harder than those. Okay? Just watch, look at your transformations, look at your domain and range. You've done domain and range in a bunch in the past. Okay? Just practice a little bit. If you get stuck, let us know. Show up in a Zoom, email us, let us help you. Okay? Good luck.